So hi guys, this is GKCS. I'm not entirely sure if this screencast has started, but I sure hope that it has. Now, how do I know that actually it has started? So wait, how do I screencast? Yeah, this is what I was seeing a few moments ago. 1 minute, Hangouts with, yeah. So let me just confirm, you can skip this part. So what we are going to do, of course, today is dynamic programming with bitmasking. And I don't have too much blackboard in front of me or whiteboard, so I'm going to be drawing on my own computer, and then you see how we solve the problem, which is this one, which is little elephant and T-shirts. So once I have the itsy bitsy irritating technicalities out of the way, we can just start. So just give me a few minutes. In fact, I had thought I'll start about 20 minutes ago, but my extreme technical skills have brought us to this place now. Go live now. Yes, of course I am. Use Hangouts to broadcast live. Okay, I think we are live. So yeah, there are 24 viewers. Hi, everybody. Can someone please comment here just to make sure that we are live? And can you tell me whether you're able to see the problem if I... Yes, no, not entirely sure. Can someone just comment back to the hi so that I'm like 100% sure that I am live? Because this is the very first time I'm doing this, and if you're seeing something odd, then please tell me also, because I would like to, I would like you to see me at 12 in the night alone at home. So yeah. Okay. Right, I'm not entirely sure. Oh, there's a YouTube page here. Oh, wonderful. Okay, fine. I'll just check that first. So that should be the live control room. Oh, yes, I am live. Oh, okay. All right. So, oh no, 1 minute. Where am I going? Yeah. So I'll just share that on Facebook if that's okay. Yeah. Fine. So, everyone ready? Let's start with Bitmask. Perfect. I'll just keep a link open here. Should I? Okay. We are. Okay. Oh, I'm so sorry. I didn't see your comments here. I was just reading. Anyway, fine. We are ready. So the little elephant and T-shirts problem. Now, this problem is a very, very basic problem when it comes to bitmask+DP, but it's not an easy problem, because the fact is you need to understand binary, and you need to understand how sets work if you're going to be able to solve this problem. So the problem, of course, is that there's a little elephant, and he has gone to a worthless party, which has lots of people, just I think 10 people. Yeah, 10 people at most, and every person can have a set of T-shirts amongst a total collection of 100 T-shirts. Okay, so here's the thing. 100 T-shirts exist. You have a set of T-shirts to choose from, but no one wants to wear the same T-shirt, otherwise they'll look a little uncool. So what you want to do is find out all possible configurations of the people in the party, such that no one has the same T-shirt in the party. Okay, that makes sense, because you want to look super cool in the party. Now what I'm going to do is I'm going to draw something with my perfect skills of drawing. Yeah. Oh God, my hands are shivering. I might get it completely wrong. So yeah. There we go. So the problem is that you have 10 people. And 100 T-shirts. Now think about the most brute force way to solve this problem. What could be the most possible brute force way to solve this problem? 100 T-shirts and 10 people. Each of them have a collection. So let's say we don't care. We don't care what their collection is. We start applying all possible combinations of T-shirts and people in this. Okay, so first we apply T-shirt number 1 to person number 1, then T-shirt number 2 to person number 2, and T-shirt number 3, and so on and so forth. So there are 100 combinations that this guy could have, the first person. right? The second person could again have 100 combinations. The third person could again have 100 combinations, and so on and so forth. So what you would end up having is 100 raised to the power n. Okay, that makes sense, because per person you have 100 possible t-shirts that they can wear. So this number is huge, and there's no chance that this is going to make any time limit. So what we are going to do is get rid of this, and we are going to look at something simpler. In fact, should I type? Would that be easier? I'll just have a look at your comments. Problem link, yeah, of course I'm going to share the problem link. I'm so sorry for this. Yes, should I type it right here, or should I'll put it in the description. Yeah, it makes more sense. Yeah, so the problem link is shared. The code is something I'm going to write, so I'm praying to God. Please pray for me too, because it's a bit scary. But yeah, so what's going on here? Oh yeah, cool, okay. So where is the problem statement again? Yeah, fine. So one of the cases that we saw is the very brute forcey way of 100 raised to the power n. That's not going to work. There's another thing that you can think of, which is recursion. Okay, so I was talking to Jatin yesterday, a friend of mine and a brilliant programmer, and he's taken a few videos, in fact, in the channel. So I was asking what's the most difficult part about dynamic programming with bitmasks, because I didn't know it. I just learned it yesterday and I started today. So he said that the most difficult thing actually in any DP problem is to think about what the state of a problem should be. So like in a state machine, that's the most difficult thing, thinking about the state. What parameters should it have, and how we should describe those parameters. And then he said that the recursion is always easy, that you can think about what states you can move to if you can define the state itself well. So what we are going to do is we're going to think about the state well first. Okay, so here is one of the ways to think about the state. What do we need actually in every possible state in this problem? So we have t-shirts and we have people. Okay, everything else is constant. The kind of t-shirts that they can wear, or the kind of options that they have, is constant in any given state, right? But the people and the t-shirts change. So one way to do this is to keep a set of people, right? And a set of t-shirts. I swear it's not my handwriting, actually. It's just a terrible pad I have. But anyway, yeah. So here's the thing, set of people and set of t-shirts. Now, how many possible sets of people can you have? You have 10 people, right? If you have taken care of one person, then that person is out of your set. If you have taken care of two people, then your set is of size 8, and so on and so forth. Now, what we are going to do is we are going to represent this set of people in binary. Okay, if that person has already been assigned a shirt, we are going to give them value 1. Been assigned a shirt, we are going to give them the value 0. Right? That makes sense because they just have 2 possible values, and so we can represent them efficiently in binary. Get your mind around this, because it might be a little difficult if you don't know about binary. But 2 raised to the power 10 are the possible combinations we can have from the set of people that we have. Okay, and the set of t-shirts, again, can be represented using binary again. If this t-shirt has been worn by somebody in the set of people, then you clearly say that that is set to 1. Otherwise, it is set to 0. And I better talk about the constraints of the problem first. There are 100 t-shirts and about 10 people. So you see something funny happening here. Wow, what a way to draw this. Yeah, 10 people, 100 t-shirts. So yeah, this is one way to represent every state in the problem. Every state in the problem can be defined by the number of people who have been taken care of and not taken care of, and the number of t-shirts assigned and not assigned. Right? That makes sense. What do you think the time complexity of this is? I'm going to go for red over here because you can guess. The time complexity is not too good. 2 raised to the power n into, because this is a tuple, this is a Cartesian product that you can take 2 raised to the power k. The k is the number of t-shirts, which is 100, and n is 10. So essentially you have 2 raised to the power n plus k, which is 2 raised to the power 110. Now, this number is ridiculously huge, of course, and it won't pass any time limit. But the important thing is we have thought of a valid state. Here's the thing. Direct I went to Bits Goa, and I was there taking a problem very similar to this using bitmask and DP. And what surprised me was, so in fact, I didn't know it is bitmask and DP then. I realized it a few hours ago. But here's the thing. 2 raised to the power n is something that you can afford. Right? 2 raised to the power 10 is fine. That's around 1,000. But 2 raised to the power 100 is going to be too large. So you essentially want to get rid of this term. But a simpler way to think about this problem is to think of the number of people who have been already taken care of. So let's look at it that way. Does it matter to you how you satisfy the constraints for the people? Right? You want to find the number of possible ways in which you can assign t-shirts. And basically you just need to satisfy those constraints. You don't need to take care of in what order are those constraints satisfied. So you can say that any state can be defined by not the set of people, but the number of people from 0 who have been satisfied. Okay, the first person we are going to actually satisfy is person number 0, and then person number 1, and then person number 2, and so on and so forth. Does this make sense? I should be reading the comments actually from time to time. Yeah, makes sense? I'll just have a read. Yes, a bit of network issues, I guess. Right. Right. So I'll make that assumption that it is making sense. So yeah, you can keep the ordering aside, and the 0th person, first person, second person, this is the order in which we are going to actually satisfy all the constraints for people. Now, let's remove this entire thing and get to the meat of the problem. What you can do now is just keep a single number instead of a set of people, and keep a set of, what was it again? T-shirts. Yeah, you get the drift. Yeah, this is nonsense, but yeah, set of T-shirts, and the number of people you are satisfied at this point. What happens suddenly? This number can take at most 10 values from 0 to 9. And the set of T-shirts can still take the same number of values, that is 2 raised to the power k. But now each state in our DP has been basically squashed. It's now just 2 raised to the power k into 10 states, possible states that you can have. Okay, and from here you get the interesting idea of k is the larger constraint. What you should have done was not gone for reducing the number of states from n. You should have gone for this guy. So how can we do that? The set of T-shirts that we have to be taken care of. Right. So what we are going to do is we are going to assign the 0th T-shirt to every possible person who can wear it, which means there are 10 people. Whoever can wear the 0th T-shirt will be assigned that T-shirt, and there will be another recursive function coming out of them saying that now T-shirt number 1 needs to be satisfied. And from there, T-shirt number 2 needs to be satisfied, and so on and so forth. Okay, so first T-shirt assigned to as many people as you can. Their respective states will give more recursion, and from there you'll go on to further states. Okay, that's the general idea. Now what happens is, instead of this number, we need the number of people who have been assigned T-shirts. So that is set of people now. So we are back to square one almost, except that we have actually solved the problem actually. Because set of people, comma, number of T-shirts is 100. So from 0 to how many T-shirts have been assigned is what you need to keep here. Okay. So now look at this. The first parameter can take 2 raised to the power n values, and the second parameter can just take 100 values, or k values rather. So the time complexity, rather the number of states, has been brought down to 2 raised to the power n into k. And now we can solve this. Do you know why? because of dynamic programming, because we can actually store for every state what the answer is. Right? You reach any state, you're not going to compute it again and again and again. We can store this, we can memorize this state. Or the second thing we can do is we can move from the last layer state, like we discussed in the previous video, using the bottom-up approach. Storing would be the top-down approach, and actually moving layer by layer forward would be the bottom-up approach. You know what? I don't really know what I should use. Should I use the bottom-up approach or should I use the top-down approach? Let's think about it. So if we move from here, then I'm taking one T-shirt and moving forward, and then the second T-shirt and then moving forward. Is there a possibility? So this seems like the bottom-up approach. Yeah. Layer by layer by layer. Yes. So one person is assigned, but not really, because the recursion, it starts here and then it's going to go deeper and deeper. No, I'm not entirely sure. I think I'll take the safe route this time and go for the top-down approach. So what I'm going to be storing is a DP array where the set of people, which is 2 raised to the power n, which is 1000, and the number of T-shirts assigned till that point are going to be stored. So that 2D array is going to have 1000, 1000 not, 1000 into 10 values. Okay, so that's 10K values. No, this is 100 rather. So that is 1 lakh values, 10 raised to the power 5. Pretty easy to actually store. Right, this makes sense. Doesn't make sense to you. I should check that actually. Guys, you, I mean, is this fine, or are there any doubts that you have? We should probably clarify all doubts first before we jump to the code. Because according to me, this problem has been solved, and we're going to actually code it and then try to submit it on CodeChef. So what do you guys want? Do you want me to get like clarify doubts, or should it be code? Have I lost my internet connection? No. Yeah, it seems fine. Okay. Maybe I'm looking at the wrong thing. Yeah. Don't really know. Oh, start coding. Amit Kumar says start coding, so I'll start coding right now. Fine. So fine. You know what I'm going to do? I'm just going to take the input, and that's going to help me understand what's happening. So there are a number of test cases and n, which is given to us. Anything else? Yeah, it's clearly written here. Number of test cases. So fine, there's some standard stuff we need to do. And I'm going to show off a little bit about how fast I can type, or rather I'm going to actually embarrass myself. But so here's another thing that I need, a solver class. It's going to actually solve my problem. Before that comes all the stuff, which is like buffered reader. So I'm going to be programming this in Java, but if you like something else, then you could program in that. One of the things which strikes me that I've never programmed in another language, apart from in that office, a little bit of Python, but even there, it's a struggle sometimes for me to understand how to switch to another language, although it shouldn't be at all. And that's why I think it's a little rich whenever I say that the algorithm is the only thing that matters, the language doesn't. But really the language does, and that's why you should be comfortable with one language at least. Otherwise, it gets a little messy. Okay. Plus, I think the ID is something pretty important if you're looking for quick gains. In a contest, you don't really want to be thinking about silly stuff. So, what's the input again? N will of course come in. What else is the input? Each of the next n lines contains at least one and at most 100. Okay, so these are the sets that they have. Fine. So int n, right? Int n, yeah. N is equal to yeah. By the way, guys, can you see me coding here? Because it would be weird if you can't. Yeah, Akshay, don't worry. I'll change that to main. So I think solution or main are the things which work. So yeah, I'm not entirely sure about that also, but yeah, I'll convert it to main. But are you guys able to see me coding? Yeah, of course you can, because you just commented on that. So of course, what a genius, Gaurav! What a genius! You're so intelligent. How do you do this? Okay. So we have n, and we have another array, which is going to be, what's it going to be? Send. So it's going to be arrays dot stream. Is it? Yeah, I think I'm going to stream it. So I've never tried this. Let's have a look if this works. So I'm reading the line now, and what I'm trying to do is, but arrays.stream, what's wrong? Okay, yeah, split. I'm going to split it on the spaces, and what I'm going to do is I'm going to collect it as, so can I convert this to an int array? Map to int, flat map to int, map to int perhaps. Map it to an int. So C is going to be integer.parseInt. You don't program in Java. All these are just, semantics for Java. There's a toArray function, is it? Perfect. So now what I need to do is, of course, have a solver object. Okay, now what? Solver.solve. Oh, I haven't defined that method, so that's fine. I need an n and an a, and that should do it. So I'm going to name this better. I'm going to call it sets. Yeah, and I'm going to pronounce that very carefully. I really need this n. Nah, not really. I'm going to keep this as. And one of the things which has happened after my job is I've become very particular about good APIs and stuff. So, I mean, I never pass anything which is not required. So, perfect. Now, what I need, I have n. I have the number of sets, which means I need a function here. Public. I think it'll be private, as if it matters here. Send. Yeah, but what's it going to do? It's going to actually return the number of combinations possible from this point in the recursion. So it's going to return me long, let's say. What else? So of course, we are going to be outputting with some value, some number, right? So that will be a constant. So this is a no. This is a constant, right? Mod. Name it mod. Now what? Yeah. So this function, I'm just going to call it. What should I call it? Possibilities. From this position, how many possibilities are there? And we said that it's going to contain two things. It's going to contain a binary representation of a set. So that will be people. And it's not going to change actually. And it's also going to contain something else. It's going to contain the number of shirts taken care of. So assigned is the number of shirts from 0 to 100. How many shirts have been assigned till this point? Right. So people assigned. Finish. What was that noise? Okay. Sahil, can you tell me what's not clear in this? Apart from me. Okay. So number of shirts, yeah, fine. So we are just going to solve this now, and hopefully it'll get clear later. So the people are going to be assigned, right? So what I'm going to do is find out the first person who has not been. No, that was the other way to think of it. Yeah, this is when we are assigning one by one by one. So, right, how many people have been assigned? First, you're going to return something because it's irritating to see this red mark. And what's solve going to do? It's going to say, find me all the possibilities. No one was assigned anything. So that's 0. No one is assigned. I mean, none of the people have been satisfied with any t-shirt or are wearing any t-shirt yet. And no t-shirt has been picked up to assign. So this is what we are going to be returning, right? And it's going to return long, therefore. The solver.solve actually has to be appended to this. Right, and we are just going to return the string builder. Right, that does it. Fine. We are ready with solving the problem. So the number of shirts assigned now, we are going to be picking up the next shirt to be assigned. Right, and we also need the sets actually over here. So what we are going to do is we are going to create this solver object. Should we create it every time? Should we create it every time? I think we will, yeah. It doesn't really matter. Creating a new object of solver is not going to hurt us too much. We're going to be passing in sets here. And actually, solve it. I'm creating a field sets so that every time we come to solve something, we know how many shirts can be given to person X and person Y. So are sets actually going to help us? No, we need an inverse mapping here. See, set is giving you the number of shirts that a person can wear. What we want to do is we want to find out the number of people that a shirt can go to, right? So I'm just going to invert that mapping. I'm going to keep this of size around 100, right? And fine, that will take care of itself. Now, for every person, I need to find out the number of shirts. So, right, int shirt sets, new int 100. Okay, and so for every shirt, it can go to X number of people. It's not int 100, it's int 10. Right. And now what we do is we find for each shirt, each person actually, if that person can wear that shirt. So this is the shirt that they can wear. So in the shirt sets, that person should be put in. Right, so shirt sets is containing the number of people. So this is going to be a 2D array. I don't know why I'm not thinking about that. So a 2D array where every shirt is going to have the number of people that it can be assigned to. So every shirt and number of people it can be assigned to. Okay. In fact, I can just improve on this slightly. Right. Fine. Shirt. So this is the shirt column, and the size column is going to be given by okay. So count of that particular thing should increase every time a shirt is added. Yeah, this should work. So shirt sets is what we're going to be assigning it. So what we have now is the set of people that a shirt can go to. Okay. And we have the number of shirts we have assigned up to this point and the number of the set of people who have actually already worn shirts. So fine. Over here, we need to assign shirt number assigned, this number. Right. So that is for every shirt, which can, for every person rather, which shirt can be assigned to. We're going to give them the shirt if they're already not wearing it. So if people and they're not already wearing it, what does that mean? Well, it means that if that person is already not one, so people and okay, fine. These are the people, right? So that's I. So in person is equal to shirts assigned of I. This is the person that we could have assigned it to, but we need to check if this person is not already, amongst the people. So if that person is not already in it. So this requires some binary manipulation. You'll have to check this out in the video, or I'll just share a link in the description. But what we need is this person has a binary value in this set, and we are checking if that is equal to 1 or not. So if that is 1, then that person has already been assigned a shirt and you can't do anything. So what you want is 0 here. Okay. So the person has not been assigned a shirt. That's damn good. So we are going to be looking at possibilities of actually assigning this person a shirt. So possibilities of setting people and then assigning this person a shirt. But we are first going to look at assigned +1. What we're going to do is we're going to take the new people, let's say, int changed people. What do you like to call it? And set it to people first, and then set this bit in changed people. Right, we're gonna actually set this bit to 1. Change people odd with this bit is what we have. So this person has now been set, and we have also assigned 1 extra shirt. Okay, so that's one of the things that is possible. And I think that's it. That should do the whole program, shouldn't it? Apart from actually answering this. So of course, long count, let's say, long answer is 0. And every time possibilities returns you something, answer is actually going to be that. But, okay, we're going to return the answer. Yeah, that should do it. That should do it. I'm convincing myself more than anything. Okay. We also need to mod this, with answer plus. This thing has to be mod with mod, like we said earlier. So right. Seems pretty logical and clear. Yeah. And finally, do we need to mod anything? No, 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 not at all, not at all. Right. This is making quite a bit of sense, or is it really? What's wrong here? Oh, solver. No, we don't have any extra solver there. Sets is not required to be passed. Right. Now let's have a look. Oh, we are not giving 100 shirts to everyone. It means that we are actually giving the shirts to anyone who can have a shirt, this particular shirt. Right. So what's also happening is that you could have taken it that way, that a person can wear how many shirts, but what we are trying to do is the other way around, that this shirt can go to how many people. So you can see this array over here. You can see that it's for each shirt how many people it can go to. So we are not assigning 100 shirts here. So the number of shirts you have in total, distinct, and so these are people basically. Yeah. Right. So let's go. Oh God, please work. And there was a point in, so I'm interested in trekking. And there was a point when I was lost, and that was the time when I was actually begging God that please save me, please save me. I'm getting a similar feeling now, but yeah. Yeah, but I think IntelliJ is the only one who can save me if it starts compiling anything at all. Come on, IntelliJ, you can do it. I really don't know why it compiles everything every time. Oh, wow. Index out of bounds exception. That's interesting. So what does it say? It says that the count has been exceeded. It seems like person at that point. What could possibly be wrong here? People of I. No, that's very weird. People actually contains the shirt number, right? So count of shirt number. Yeah, that's okay. That's okay. Count of shirt number plus plus. What could possibly be wrong here? Okay. First of all, let's just bring it down to one test case maybe. Yeah, just one test case. So this is the test case which is probably failing. Still the same place. Anyone have any ideas? You're a cheat. Oh yes, of course. I guess it did. No, that is. I think that's in C++, and not just that. Why isn't this magnifying? Go, go, go! Magnify, magnify. Whoa! It's not magnifying. Too bad, isn't it? Come on. Well, I'll just share this on GitHub. You can check it out here, of course. Tshirts. Wrong answer. Of course, I'm going to be solving this. You can see my entire history. What a mess. So where's this Tshirts thing? But it hasn't been pushed or something. Let's push it, please. Thank you. Thank you. Sometimes IntelliJ does some seriously dumb things, you know. Yeah, right, fine. No more need for ranting. It's probably going to be Tshirts. Yeah. I'm just gonna hit this. So how can we solve this now? Well, the index is out of bounds. That's fine. No, it isn't actually. But what I'm going to do is I'm going to actually print out people. Third person. get this done again. Oh, it gave an answer. That's weird, isn't it? Oh, it gave the system output. Okay, yeah, fine. Another thing I want to do is actually just zoom in. Oh, it's not going to zoom in. Well, 3 is the count, and our index out of bounds 3. Okay, that's fine. But so count of 3 is what is giving an exception, or is it just, you know what? I'm going to print count of 3 also. Just to be 100% sure where the error is. Right, so the error is right here, over here, count of person. So count, what is count being assigned to? People.length. So the number of people that we have, actually, what would that be? 10 people. Yeah, so what could possibly be the issue? One shirt can be assigned to at most 10 people. How? What's wrong? Well, 3 is the size, and why is it ever going to 3? Then that's weird. It should never have gone to 3. The count of person, so person is people of I. People is coming from this array above, and what have they done? They have done one-based indexing, is it? Just to make things more interesting, yeah, they've done, I think they've done one-based indexing, haven't they? The number of t-shirts, yeah, for every integer denoting number of persons, each of the n lines contains at least one and at most IDs of the t-shirts. But what's that? I don't know why it's taking me so much time to figure this out, but wait, if a person and, okay, count of what? Count of that person, right? Which is people of I, which is people of I is a shirt ID. Yeah, people of I is a shirt ID. Yeah, so these are actually the shirts they can wear. So I'll just rename this. Yeah, and now I think I understood the error. This is a shirt. Count of that particular shirt can easily, of course, extend 3. So this is actually, this size should be 100. Yeah, pretty stupid error actually. How do I think of it? Of course, count has to be from 0 to 100, 0 to 99 basically, because every shirt will have a particular count. Answer is 0. Oh, okay. Did it read the whole thing, or was it answering even before that? I don't think it read the whole thing, but yeah. So why is it 0 now? Return possibilities, answer is set to 0. So every time we try to return possibilities, what I'm going to do is I'm going to actually print out the answer. Is answer ever changed? We'll have a look anyway. In fact, we'll just see whether this method is being called at all. This method is being called internally, but here's the thing. Right, people assigned. Here's the thing, right? Shirts. I mean, when do we actually stop? What is the base condition? I don't know why I didn't think of this. If assigned is equal to, if all shirts have been assigned, if shirts length, then you return, what should we return from here? Well, then you return 1, of course, because Yeah, you're done, and this is a possibility. Otherwise, you don't return anything. Otherwise, I mean, yeah, you came up to this point. That means that you're done. But there is a scenario when, oh yes, of course, if all the people have been assigned a shirt. So what's going to happen is if people is equal to 2 raised to the power n basically. So 2 0 2 3, then you do this. Otherwise, you put a 0. And this is not correct. I need n here. Shorts dot length, right? I'm actually going to be storing this as a dot length. Shorts dot length. I'm going to be storing this as a field. One length minus one. What I've done basically is 2 raised to the power n minus 1. So all bits are set, meaning all people have been assigned shirts. This is binary stuff happening right here. If they have been assigned shirts, then you say, yes, this is a possible combination. Otherwise, you say that, no, this won't work out. So yeah, this was a base condition, and it's kind of required if you want the right answer, that is. But what is wrong here? Right, hi Avish. Now what? Why is this not changing? If it has been assigned, short sets dot length. So assigned is something that we do add to. I'm going to be printing the answer, and before that, I'm also going to be printing out something else. I'm actually going to be printing out people, and I'm going to be printing out assigned. So integer dot binary string. I want this in a binary string. Yeah. And what I really want to do is I want to actually see how many shirts are assigned and why or how it doesn't really work out. Okay. Okay. So the first thing, 0, 0, meaning no one was assigned. No, of course, yeah. Now we go to 1, 1. Is it? Okay, so the first person is assigned something, and the second person is again assigned, or rather, one shirt is assigned to the first person. We should probably have a look at what shirts can be assigned. So 3, 5, and 8, 10, 100 are what can be assigned. So first person is assigned shirt number 1, but shirt number 1 does not exist in their inventory. Does it? Shirt sets assigned. I'm actually going to be printing out. Right. This is a mistake. Shirt number 1 cannot be assigned to anyone. So technically this should give us 0. Right. And what's happening is we come here, we say that from 0 to nothing. So we skip this entire array and we return the answer. So shirt number 1 can be assigned to no one, and we are therefore just returning an answer which is not making any sense. So what we should do is we should go for shirt number 1 and then shirt number 2 and shirt number 3. So if assign.length, this makes sense. This thing is making less sense. All the people that it can be assigned to, give it to them. And once they have been given this, what you should do is return the answer. Yeah. Okay, either you give this shirt to everyone, right? Or you give this shirt to no one. That's a possibility which I did not take into consideration. Yeah. You either assign this shirt to everyone that you can, or you don't assign this shirt. Right? Does that make sense? Yeah, I think it does, because there will be possibilities when a shirt is not assigned to anyone. So yeah, that's one of the things that we should take into consideration. So answer is going to change a little bit. We are not going to be assigning this shirt to anyone. So it won't be changed to people, it'll just be people. And we will be getting rid of one shirt, the current shirt, right? So yeah, that's I think the edge case. A little bit of preparation beforehand might have helped, but I really wanted this to be ad hoc and fun to solve, like on the spot. My God, what was that? So rid of these guys. Yeah, and let's just print that again. Seems like lots of possibilities exist. 198, they say. I think I'll get rid of this paintbrush. No, thank you. I won't say that piece of art. 4. Just 4. 38300. What the hell? Oh, okay. No, the base condition has suddenly failed. We want all people to be assigned a shirt. Yeah, which is fine. So the length is going to be the 2 people, right? So this should be 3. So 1 1. Both the people should be assigned. God. Right. Let's now think about this calmly. Yeah, I think we have wasted enough time just debugging and trying to get the solution somehow. So let's think about this. The solver gets a set of shirts. We inverse the mapping to get the number of people we can give the shirts to. So the number of people we can give the shirts to. Okay. Now, is that happening correctly? Let's check that out first. So what I'm doing, of course, right now is checking if this inverse mapping is happening properly. And then we'll just break this down completely till we solve the problem. So this is making sense because nobody has been assigned anything. And the number of people who have been satisfied is 0. So this is fine. Everything till now is fine. Let's just make sure that the inverse mapping is happening proper. No, it isn't. It doesn't seem like. Right, everything is just wrong. These are people that the shirts can go to. So yeah. The people that the shirts can go to. 0 0 1 0 doesn't make any sense. Fine. Shirts dot length. How much is that? That's how much we need people dot length actually. everything is 0 except this guy over here. So 3, 5 is what the first person can wear. So shirt number 3 is 0, 1, 2, 3. This should have been assigned to person number 0. Uh-oh. Now, technically what's happened is person number 0 can wear anything. Yeah. Why is the count equal to 0? Oh yeah, of course, because that's what's been done here. So the first person can wear anything. The second person can wear 8 and 100. So 8 and 100 is what they can wear. Okay. Should be 101 actually, technically. That is weird. Oh yeah, of course. We didn't even go to that answer. So here's the problem. It's that we didn't have enough shirts, first of all. And 1, 2, 3, 4, 5, 6. Why 6? So that is number 5, right? 5 has 1 here, which means people of shirts of I. Oh, okay. For the first shirt, which is 3, increment its count. So count of this should have increased after inserting I. Which is 0. Okay. Second thing, 5. So shirts of I is 5, but count, I is basically 1. So at 1, 1 has to be inserted at 5. Right. Right. So this complete thing is completely wrong. The inverse mapping is wrong. Just I don't know. I think the entire thing is wrong. So what's happening here is that we are sending in the set of shirts, right? And I'll just yeah. Well, here's the thing. We have the set of shirts. What we are doing is we are trying to find the people. So for each shirt, the number of people that we can put in there. Why is it shirts.length again? Again, I didn't really understand. Okay, yeah, this is people and count. Yeah. So for every possible shirt, yeah, we are taking the shirt number. We're taking the shirt number, and we are saying that for this shirt number, person I can wear it. Okay, so 3 and 5 basically have 0 and 0 inserted into them. So here's the thing. How do I prove that? How do I prove my hypothesis? I could write a debug statement, but yeah, I think I'll write the debug statement. So 3 and 5, that's what we'll do. I think it again does a little fancy things for debugging, but we'll get there. Line 55, are you sure? Let me just have a look. Assigned +1, no, we have assigned a shirt, right? So we have changed the number of people and we have assigned a shirt, so it seems sensible. Right, shirt. Shirt number what, 3? Oh wow, we have reached 3 anyway. So shirt number 3 is what we have. At row 3, be inserting at the first position this person equal to 0. Okay, So that's what we have. Now, shirt. What is shirt equal to? First of all, 5. Yes. So at row 5, person 0 has to be inserted. So this is making absolutely no difference because person 0 is already inserted there. If you see the array of people, everything is 0, 0 anyway. And people array, every row has 0, 0. So this is making absolutely no difference. So the first row is making absolutely no difference. Now we come and increment I, which is going to give us what? No, there are 2 people. So is size what? Shirts is of size 2. 3 and 5, that's it. No, that shouldn't be it. Oh god, I've taken a single line, have I? Wow. I'm a genius. I didn't actually see the problem statement. So stupid. And in fact, the whole thing is making sense now because this is the number of shirts every person can wear. So it's going to be a 2D array, for God's sake. And that means that this is a 2D array, and sets of I is going to be this. So this is going to be of size number of people and the maximum number of shirts that they can wear, right? Okay. And now I need a for loop. Don't worry, I'm going to check the condition here just sometime. Right, for every person. So for every person, I'm going to keep things simple. This is going to do this, and solver is going to be taking a 2D array. Now the whole logic will fall in place because till now the whole thing was just like goddamn ridiculous, to be honest. So this is happening for one person, right? Per person. So what we need is something slightly different. We need this to happen for each person. So this is going to be J, this is going to be J, this is going to be J. And shirts itself, shirts.length, that's fine. Shirts of 0.length, shirts of I.length is what we're looking at. Basically 100, to be honest. What's that to be honest here? But yeah. 101. Before I make that mistake, 101. Because shirts are labeled from 1 to 100. Right. So everything seems a little better now. This is the shirt. That's the count. Yeah, let's just confirm that. This is the person, right? This is technically the person that we are at. This is the shirt. Okay. This is the shirt. And these are, what do they call it? Wardrobe, yeah. The wardrobe of this person and this shirt will give you what? No, this is not the shirt. This is just the index. Yeah, that will give you the shirt itself. So this is the shirt. So yeah, shirt here, counter that shirt. Fine. This should work. What now? Person wardrobe.length. What is wardrobe.length? It's equal to n. So yeah, I mean, why is it wrong here? Index 101. Wardrobe. Is that 101? Yes, it is. So what is possibly wrong? 2. So of course we have done something wrong with person here. Right. For every person, we made an array. Oh yes, of course. So we are not sure how big this array is. And in fact, 101 is not the right thing to do here. It's just wardrobe of I dot length. Okay, person dot length. This person's wardrobe length. $398. Well, that's an answer, but a wrong one. Why? Okay. You can safely say that this was not what I was expecting. The code should have worked till now. But I'm not going to give up. I'm probably going to be doing a small session on Bitmask offline because that's so much safer. Because this has just become a mess. But I'm going to solve this. I'm not going to give up. I'm actually going to be thinking and solving this to the point that it is solved. So yeah, here's the shirt. So what I could do, of course, is print out every shirt that is possible. As I start to string. When did I actually start this? Around 12 o'clock. So it's been about an hour. Right. What? Don't tell me we're back at square one. For God's sake, no. What is truly what is happening here? Well, even now the shirts are not proper. Like the person I want to assign it to is not actually getting it. So how do I actually give it to the person I want to assign it to? First of all, person number 0 should not be considered. Shirt, yes, this is a position where I can. So count is another thing that I should have actually taken care of. People is one of the things. There's also count. Count should be a field. Right now, here's the thing. Every person. So every shirt that we're actually assigning here. So this is not people anymore. This is number of people that you can assign a particular shirt to, right? So this is not this length, assign dot length. It's the count that assigned value has. So at least this should get rid of any future bug. I'm not entirely sure if this will work in just one shot. But yeah, this is one of the things which has definitely gone wrong. 4 is the answer here. And for the love of God, actually, I'm praying that like, let's just try this. 4 is what is the expected output. Of course, I could have just printed SOPLN 4. It would have been the same thing. Desperate man at the end of his 6. Why would you print out 6? But actually, I'm feeling much better now because we are very close to the answer. So 6. Right. This is the thing. This is it. 101 501, 2, 500, 100. Okay. Why isn't it 6? Why isn't it 6? Why is it just 4? Right, that shirt has been assigned. Okay. So what's probably happening here is, why am I printing out 6? It's probably looking at every possible combination. Is it? Uh, right, now we can actually come here and look at the meat of the logic. So firstly, it'll be 0, 0. Nothing. No one will be assigned any shirt. We'll go to the next shirt. We'll see that up to the point that we come to actually 5. So let's just do that, right? So that things are simpler. The 5th shirt will be assigned to the first person. It just happened. Oh yeah, 3. So 1, 3, and 6. Yeah. So the 5th shirt will be assigned to the first person initially, and then the second person can wear just 2, and the third person can wear just 100. So that's one possibility. Similarly here, another possibility is 2 and 5, and over here there are 2 possibilities: 2 with 5 or 2 with 100. So in total, just 4 possibilities. Now, why did it give out 6? Why would it ever give out 6? So we can print that out, right? We can just give out the answer right here. Come on, please work, come on. No, in fact, it's not going to work, but at least I'll be able to tell where the debugging issue is. Come on. Fire away. So I'm just going to make another thing like over here. I'm just going to make sure that if count of assigned actually exists. Oh, okay. That gives me another small idea. It's already checked. I mean, this can't be assigned. So if count of assigned actually is equal to 0, is greater than 0, then and only then should we actually think about leaving this shirt. Otherwise, we don't need to. No, what am I saying? Do not take the risk. The thing is, if count of assigned is 0, this shirt can be assigned to anybody. But I don't want to skip that shirt at all, so this is fine. I just want to see some debugging over here. Another weird thing that I just noticed is assigned will be incremented all the time. There will come a point, okay, yeah, but the people won't be given enough shirts, so that's fine. So initially we come here, we have 5. 5 gives an answer of people plus signed plus yeah, this is what I want. Okay, very close to the answer now. I don't really understand why it's not working, but yeah, we will understand very soon. So 5, when everyone has been assigned, that's very weird. So the first thing that was printed out is number of people of 5. Okay, so that is 4 plus 1. So basically we can print this out in a better way, because I want. Okay, so basically the first and third person were assigned all shirts, and the answer turned out to be 2. Right, 101. This means that the first and third person were assigned all shirts, and the answer was 2 then. So why is that? Well, 100, meaning that the last shirt was not assigned yet. Last shirt was not assigned. Oh God. 101. 101. Where is the 111 that I'm craving for? Oh yeah, of course it won't happen. Right. So let's just think about the. Should I draw it? Yeah, I think no. Let's not draw it. The first person is given the shirt number 5. That's a nice thing. This is the first person who's given the shirt number 5. Then the second person is of course given a shirt number 2. They have absolutely no choice. The third person now. So the second person is not assigned, is it? Yeah, the second person hasn't been assigned anything. So first person is given the shirt number 5. We go forward to shirt number 5. Here's the thing. So the first person is assigned shirt number 1 here, because that's the smallest in the number of shirts. So 1 is assigned to shirt person number 1. 5 is then assigned to person number 3 here. Okay, that's one possibility. And then 2 is assigned to this person. Okay. To the second person. Now, here's the thing. If you assign 1, then you can assign either 5 or 100 to the second person. And so you have 2 possibilities. So this seems to make sense. This seems to make a lot of sense. When just 5 shirts were assigned, so this is taken care of. The answer comes out to be 2. So if 5 is it 2? No, the answer should be 1 here. The answer should have been 1 here. This seems wrong. Is it? No, 5. You know what? Rather than debugging it, let's try and understand if there's a logic error. If all the shirts have been assigned, that's fine. If the answer is 0, so now you know the technique for actually solving problems in an easy way, because it's just sit down and debug the hell out of it. So, yeah. So this base condition is that all people, so all shirts have been assigned. All shirts have been assigned. All shirts have been assigned. So does that happen? Does that ever happen? Yes, you will go on to the point that all shirts have been assigned, and then you will say that is everyone happy? So that will happen at a certain point of time, and yeah, this is fine. So whatever error exists right here. Let's go for this condition. No, this is ridiculous. So the answer is set to 0. This is the point that we are looking at now. Answer is set to 0. We go for all those people that can be assigned shirts. Basically, that's the count of assigned. And then we say that this person is who you can assign it to, the ith person you can assign it to. If this person has not been assigned already, okay, then you say that we are going to be setting that person to 1. We are going to be taking possibilities to it, assigned plus 1. So we are going to be moving on to the next person, and we are going to be setting this person to 1 and then moving forward. Yeah. And finally, there's another thing that we need to look at. We say that if this person was not assigned this shirt at all, then the old people will stay, and we just move 1 forward and go here. Right. Right. So I think I know the error now. So I'm just going to draw this out. Okay. Question is 501 to 500. 501 to 500. So this is the question, right? We come to the first T-shirt and we say that the first person can be assigned. So now the binary array is 0, 0, 1. That's people. And the number of shirts you can wear are from basically one shirt has been assigned, right? So the assignment number is now 2. We have incremented by 1. So at this point, that is one possibility. The second possibility is, in fact, this is the only possibility, right? Yeah, this is, let's think about this. 1 is assigned to the first person, and that's the only possibility, yes. So this is the only possibility. From here, we have more possibilities. We have the next shirt 2, which can be assigned to just one person. So that's another single possibility thingy. So 1, 0, 1, 1 is the binary number, and assignment number is 3. Now you keep going forward till the point that you hit 5, which is one of the possibilities from here. So over here, that'll be 1, 1, 1, and you're done. That is one possibility. The second possibility is when you hit 100. So that is 1, 1, 1 again, and you're done. Right. Now we are taking care of first shirt being 1. First shirt being 5, the first person being assigned 5 would have given you uh, 2 already assigned. That's a little weird. See, the first person being given the shirt 5 is impossible in our case, is it? Because the first person, if he's assigned a shirt 5, we can not go to 2. Is that what we are doing? 1 is moving on to 2. Right. I think what we have done is we have counted uh, shirts and assigned shirts in a weird way. So we had the set of people we can assign it to, and we had the shirts we are assigning from 0 to n. Now, is that right? I pick up the first shirt, I give it to anyone, and then I look at the remaining shirts. I should look at the remaining shirts, not the shirts in front of me. So, okay. So I should look at the remaining shirts. But that's going to actually increase the complexity incredibly. There must be a better way. I pick up the first shirt. So the second one, just 1 second. Is that? Oh god. Okay. What could possibly be the problem? The first person is assigned this shirt, and now we can only move to 2, and now we can only move to 3, and now we can only move to 4. So when I say that can we try 5, we can't try 2 now because all shirts up to 5 have been assigned. So there's a problem here. Uh, it's that every shirt behind me cannot be assigned now. So after 5, 2 cannot be assigned. This combination is not possible in our algorithm. And this combination is just not considered because 2, I mean, with 100, we can't go to 2, we can't go to this point. So what could it be now? What, the algorithm has gone wrong. That's the worst part. Like the assumption made was just wrong. We can't put a parameter and say that this is the shirt index that we have gone up to. We can't do that. It's just so demoralizing right now. Uh, let's think about this. In fact, you know what? It's pretty late in the night. In case you guys want to sleep, you should. And I'll just do something on this offline. I mean, I'll make a whiteboard session on this, and so you can have a look at that. I won't be giving up, of course, right now. No, that's not going to happen. I'm going to be solving it right now, but I can't think about what the hell to do in this scenario. So basically, the entire logic of even assigning people, the first n people have been assigned, that seems right. That seems okay. The first person has been assigned, now the second person is going to be assigned, now the third person. But the shirts thing, I really can't tell why it's not making sense. Like, why shouldn't that work out? Like the first person, no, wait. I'm not entirely sure if the logic is wrong, actually. That's even worse. But the first shirt is assigned, right? Now we are done with that. Now the second shirt is going to be assigned to every person. So we're not going to come here. We're actually going to go to shirt number 2 and find out those combinations. So no, this logic is not flawed. Oh, thank God for that. Right. The second shirt can be assigned to person number 2 only. Okay. Right. So second shirt can be assigned to person number 2 only. That's the only person who can take it. After that, these two will come into consideration. Second shirt will be assigned to person number 2 only. Right. That's okay. Now what happens? Do we need to check for all shirts for the second person? I think maybe. I think, you know what, this has gone wrong. Wait. Assigned should be set to 0, I think. None of the shirts, like you can choose any shirt, right? Could you do that? What is assigned telling us? Shirt number 1 has been taken care of. Shirt number 2, shirt number 5, yeah, no, assigned is fine. Assigned also seems fine. Okay. From 2 could have gone to this guy, and from there we say that 2 is going to give us possibilities for 5, possibilities for 100. Right. Okay. So let's get rid of this entire nonsense. Let's start with a simple scenario of 2. 2 says the first person could wear 5, in which case the third person has to wear 100, and the first person would wear 100, in which case third person would have to wear 5. Okay, this is what 2 says. When you pick up 2, when you pick up 1, it can go either to the first person only. So yeah, again, can only go to the first person, and it says that now there is 2 which the second person could wear, in which case the third person could wear 100 or 5. This is the story of 1, this is the story of 2. story of 5 is it can go to either the first person or the third person. In case if it goes to the first person, then the second person can wear just 2. And the third person can wear just 100. Right? And here also again the same scenario. So I think here's the place where the issues are happening. The second person can wear just 2, and the third person can wear just, the first person can wear just 100. Yeah. So 1, 2, 3, 4, 5, 6. 6 scenarios being taken into consideration, and that's what the answer is giving us. It's choosing 5 also when actually that scenario has already been looked into. So okay, I think dynamic programming is not being used like judiciously over here. We are double counting basically, right? So if that state has already been reached, you should not count that again. Fine. 1, 2, 100. No, no, no. First person gets 2. Right. So these two scenarios, I think these two, yeah, these two have already been counted, and we have done double counting here. First person being assigned 5. This was a scenario. First person being assigned 5, and then third person 100. So you see the double counting. This scenario, right, and this scenario is the same, and similarly this scenario and this scenario is the same, right? So finally, we're going to actually tear this problem apart now. So what I just need an array storing values, Boolean values. That's all. So private final Boolean values of visited, let's say, equal to new int Boolean. How big is this going to be? So I'm going to initialize this in the constructor. How big is that going to be? How big is that going to be? It's going to be equal to the number of possibilities. So this is equal to it's equal to this value over here, right? And this, the second thing is assigned, which is equal to 101. So if you have already visited it, you shouldn't count it. Okay. So if you have already visited it, you should not count it. Now, here's the thing. What I'm going to do is first, I'm going to set visited of people and assigned to true. And before that, I'm going to actually calculate the answer. So it's being set to 1 if everyone is assigned, right? It has to be set over here. It should be set to true. And if, in fact, it is not set to true, is not true, then do the remaining processing. Else, you just say it has already been taken care of. We have already checked it. No point visiting it again. For God's sake, return 0. Wow. Big Stack Overflow. The index out of bounds exception. Wow. So, okay. People and assigned, is it? 101. It actually went out of space. If assigned is equal to this dot people dot length, it's actually exceeded the thing itself. So yeah, fine. All shirts have been assigned there. Hmm. 2. Okay, that's brutal. It's 2. Let's just check if the previous answer is right or wrong. In fact, that's a simpler test case. So that's also giving us 2. So that is also gone wrong. But at least this is making sense. If it has already been visited for these many assigned, then don't basically don't return 0. Is that correct? No, it's not, because at this point visited was equal to 2. At this point visited was equal to, I mean assigned was equal to 2, and here assigned is equal to 5. So in fact it's not the same state. How do I get that in my calculations? If these many people and these many shirts have been assigned, no, that's too big a state to keep. What I really need to do is, okay, I need some sort of, is it bottom up that I need to go for? Okay, right. How do I get rid of these duplications? Basically, that's the question. From 2, I went to 5. From 5, I went to 2. And that's where the duplication has already been completed. Right, 2 to 5 for the first person, and this is 1, 5, 2. So, of course, the number of combinations here are huge. But if I could store the number of shirts, which shirt has been assigned to which person, that would give me all possible states up to this point. So which shirt has been assigned to which person, that's a lot of states to keep in and track. If the same shirts have been assigned to the same people, then I know that it's a duplicate state and I need to ignore this. But for that, I need to store too much information, shouldn't I? I should store the person and the shirt that they are wearing, which is 100 raised to the power k, like we said initially. God. Now that I have promised that I'm not going to give up, I'm not. But this seems like a battle which is not going to have any winners. But yeah, we'll somehow solve this. Yeah, assigned is what? What is assigned? What could possibly be assigned? For God's sake, you need to take the person who is what? Wearing that same shirt. Right? Can I condense that information? Can I get it in binary now? Can I get that in binary? No, it's not going to help. That's all I need to do. I just need to find out. So every state, like I said, is already perfectly defined by the number of the people who have been assigned a shirt. Yes, that's correct. Yes. And the number of shirts which have been assigned up to this point. So 5 should probably never be picked up. Going from 5 to 2, like, I don't think it's going from 5 to 2, is it? Is it ever going from 5 to 2? Like, according to our logic, the first, so 5 can go to 1. Yes, of course. And then 2 is not going to get picked up. Yeah. So 5 can go to 1, that's a fact, but we are just going to go to 100 after that. So this should never occur anyways. And look at this, 5 goes to 3. Okay, that's fine, but 2 is not coming in the consideration though. This index has already been exceeded, like assigned is greater than 5 here, it's 6. So 2 cannot be assigned to anyone now. Let's just check that. It seems like it's being assigned. So maybe we can get rid of this visited thing, because it wasn't top down ever. So yeah, that makes sense. But let's have a look at this. Right, of course, this will work now. This is going to work. Right. Okay. Now, yeah, there's a simple way to actually understand where the issue is. It's to print out over here. It's to print out over here what the answer is going to be. Here is what we should print out. Yeah, I'm going to actually keep this as answer. I'm going to be printing out answer here also. Fine, and over here, single test case. God, come on. 6, yeah, but I know where the issue is now. So 111, 101. All shirts. So of course it's going to pick up all the shirts. But look at this, 111, 111. Yeah, right. This is where the problem is. These guys here. Right? And why did that happen? Because people became 0. People are completely assigned, and assigned is fine. So I came to number 1, gave it those guys. Then I went to, was the shirt increasing? Shirt number assigned, yeah, assigned is here, right? So assigned, what about this? Count of I. It's very weird actually. This is not making any sense. Oh God, 1.5 hours for this problem, guys. I'm so sorry for this. Yeah. For, But yeah, assigned, we have assigned that. So the first person here, 0, 0, we come to 1. So initially, and then we try to assign 1, we try to assign 2, we try to assign 3. So are we checking with just one guy? Yeah, I think we are going to one, and we say with, or rather we're going to zero first, and we say fine, assign zero, and move forward. So zero won't work out. This will fail, right? Then we go to the next guy. So here's where assign just got incremented, right? So we went up, we incremented all the way up to one, and over there one saw its possibilities by being included, and then saw its possibilities by being excluded, right? So there's a particular point when, of course, a one is being included, everyone is excluded except five, and then five goes forward and checks out its possibilities. But it really shouldn't, because with five being set for person number one, it's already been checked, right? Yeah, so that's happening. So there is duplication. There is duplication here, because we are also checking for places where when the thing doesn't exist, right? So right. So what should it be? Hmm. Okay. So duplications exist. Let me send it. Five, 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 five. Five goes ahead and sees that there is nothing that can be assigned. Absolutely nothing. Yes, so it should not, in fact, create any problem at all. If nothing was assigned to none of the people and five existed here, it should have gone forward and assigned nothing. So that is interesting. This guy, he needs to be picked up and printed out with assigned +1, making the assumption that none of them have been assigned up to this point. Right. So now I can remove these things. Right. Where is anywhere else? It doesn't seem like there's any other place where it's there. So hmm. Even now we are debugging, but I have this feeling that it's just one single line of code which is just destroying the entire thing, Mm, possibilities 101, 102, 100. So there are none, and all the way up to 6, which gives you one possibility. That's how weird the whole thing is. 6 possibilities. If nothing is assigned till point 5, so nothing till 5 is assigned, and we have this as our answer. So what's it saying? It's actually going forward and not assigning anything. That's so weird. Like, assigned is 0, assigned is 1, assigned is all the way up to 100. Okay, we are going all the way there. And then 6, 1. 6, 1, which means that, 6, 1 means that from possibility number 1, of course. Yes, that's okay. So if the 0th guy is not assigned anything, then yeah, we have 6 possibilities. Okay, that's fine. And if the second guy is, if the first person is not assigned anything, that gives you 0, which is weird, which is pretty weird, because actually that should be 2 assignments there. Should be 2 assignments there. Yeah, should be 2 assignments there. Okay. Short number, so that's the thing, right? If you don't assign short number 1 to anyone, then there should still be 2 assignments. So what's happened is short number 1 has not been assigned to anyone, and we moved forward and nothing worked out. You know, guys, I strongly suggest you should probably let this one go. But I won't. But yeah, but still, I mean, it's actually going to be a disservice to you guys to actually watch this and spend so much of your time just looking at me debugging a solution which is supposedly extremely simple. So I would suggest you don't watch it, but I'll just get it through because it's gone into my ego now. And I really can't believe that I couldn't solve this till this point. It's 1.5 hours. Which is not a good sign for the rest of my live videos. But come on. Okay. Fine. Enough. No shorts assigned, 6 possibilities. 1 short assigned, that is short number 1 assigned, should have given me 2 possibilities. So where are my 2 possibilities? I'll just check that. Short number 1 already assigned. That's fine. That's fine. 2 could go to 5 and 100, and then they themselves could go to 105. So there's a bug right here. I know that there's a bug right here. So there's a bug in the function right here. So let's think about that. Yeah. Answer. Get rid of these worthless comments. I've had enough of them. I'm just gonna find out what the correct recursive function is, and that's it. Ooh, what the hell just happened? Yeah. So if 101, so this is fine. This is fine. Okay. Short number 1 has already been assigned, right? So we are at basically. So let's just do that, right? Short number 1 has already been assigned. We can do that. We can debug this. So what I'm going to do is I'm going to move to 2, short number 2. This should give me an answer of 2, but it's giving me 0. So that's where the issue lies. No, don't run it. Just debug it. Yeah, debug. Come on. Right. No, let's go to the next point. Yeah. So assigned is what? 1? No, 0. Boom. Assigned is still, no, assigned is 1 now. So okay. So nothing. Yeah, that's fine. So assigned is now 2. Yes, this is what we are looking at, aren't we? 1. Yeah, I know that part. So let's just go to answer is equal to 0. Fine. Counter assigned. Sign is equal to 2, meaning we are going for the second shirt, aren't we? Yeah. 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 So fine. And people is 4. So no, I want assigned equal to 2 and people equal to, what do they call it? Sign equal to 2 and people equal to 0. Right? Yeah. So this is not what I was looking for. Assign 4, assign 5. Simpler way to do this is if I put a debug statement right here, and now I'm going to run the same program with the same input. No, Cubers, you didn't really miss anything, to be honest with you. Maybe I'm being harsh to myself, but a complete mess that's happened till now. Okay, boom. So we are here, finally. Now, 2 people are assigned. I mean, rather, we have ignored shirt 1, and we are going forward. So this is not going to work out, of course. Answer is still 0. So people is 0, and we are now, yeah, count of assigned. So what is count of assigned here? Count of assigned should be 0, shouldn't it? Yes, it should. So, okay, that is weird. No, in fact, yeah, count assigned does exist because there's just one shirt that it can be assigned to. So fine. I mean, there's shirt number 2 can be assigned to person number 2, right? So that's fine. This person is person number 0. Gotcha, didn't I? People assigned is 2, right? So people who assigned can go for is 0, 0, 0. No. It can go for 1. It can go for 1. Okay. Okay. So this one, people of 2 should have uh, the number 1 here. So it can go for 1. What's the count of this thing again? Count of assigned. Yeah, that's what I want. Where's count? Count of assigned is count of 2, which is 1. Yeah. So it'll take the first guy, and that makes sense. Count of assigned should be 1, but people are assigned is a mess. So people are assigned. What do you mean by index? Oh, I think I've got it wrong. To this. So what would happen is I would go to every wardrobe. I would take the shirt at that index, and I would say that that person can be assigned that. Yeah. So what's wrong? So people has an issue. Shirt number 1 can be assigned to just person number 2. Shirt number 2 can be assigned to just person number 0. No. Shirt number 3. What the hell is going on here? This is entirely wrong. People of shirt. Why isn't this correct? What the hell? I'm starting to doubt the old code also. people of this shirt at this index should be this. Now that should help a little more. At least we have something inverse, which is wrong. So maybe, just maybe, if that is fixed, something can work. Come on. Right. So what is Solver now? Solver has people in it. People has. So what I really want is for every shirt, so every row, I want the number of the people who can actually wear that shirt, right? So shirt number 1 can be worn by person number 2, is it? Console? Shirt number 1 can be worn by person number 2? No, not really. No. Shirt number 2 can be worn by person number 1 only. That's wrong. Shirt number 5 should be worn by 2 people. Okay. Person number 0 and person number 2. Shirt number 5 should be worn by 0 and 0. So that's it. That does it. This is entirely wrong. Shirt number 5 can be worn by 2 people. So of course this is wrong. So index is going from 0 to this. Count is incrementing. But why is this going entirely wrong? Oh, okay. Wardrobe.length. Let's convert that to an indexed array. Now, this is what I was looking for, I guess. Yeah. Fine. I think this is it. Yeah, answer's coming out to the 4 now. And you know, if CodeChef gives me a wrong answer now, I'm just gonna start crying on live cam, like, please no, please. 4 and 4. Okay, so where is the system statements? Is that it really? Why are there so many spaces then? This is not making sense. Why are there so many spaces? 4 and 4. Okay. For God's sake, CodeChef, please work out. I mean, rather work. Workout is somebody else's job. Right? Can I? Okay. T-shirts. CodeChef. What's the practice problem? T-shirts. That's fine. Let's go to the editorial. I'm not going to look at it, I swear. I mean, I didn't look at it, and that was the biggest mistake. If this goes wrong, it's going to be such a joke, because it's been 2 hours since I've been coding this. Oh, thank God they've actually labeled it medium, because had this been easy, it would have been a serious detriment to my programming skills showing off. So the main function is right here. We have solver. I hope I haven't messed up anything. Well, let's see. It seems like it should work. Yes, it should. So let's just submit. It could also give a timeout error for all I know, because the number of states technically are rather large. Or are they? No, they aren't. They aren't. Yeah, they're the same. So come on. Work. Please. For God's sake, I'm sure you just time out or do some perfect. Wonderful. Thank you, CodeChef. That's all I needed now. Just a timeout. We all need a timeout, don't we? So of course, here, what could possibly be the slow thing? It's the recursive function. Is it really the recursive function? Perhaps, maybe, yes, it could be. So what I should really do is, or maybe I don't really know. Top down is not going to work. So bottom up is required here. Perhaps, like really, perhaps. Okay. Top down, bottom up. What do you think, guys? What do you think is the approach? Okay. What are you guys talking about on the chat? Uh, all right. Interesting. So, solution which is timing out. Like this solution requires a bottom-up approach. Our solution, current solution, is a top-down approach. It's a recursive one, so it seems like it is not going to be fast enough. Now, what could possibly speed this thing up? So initially, if everyone is assigned something, so if changed people, yeah, here's the thing. If assigned is equal to people or length, so this is a constant thing, right? And if people is equal to this, then you know that it is 1. Otherwise, you know that. So, okay. Our bottom approach is going to be easy to code. We are going to be keeping the same things, and I'm just going to call this possibilities too. I'm going to rename it later. But here's the thing: you need to just have a DP array. So private, what the final, what long, yeah, DP, so the new long number of people. So that is exactly this. And assigned, so that is equal to 101. Initialize that in the constructor to this value. Fine. So this is your DP array. And what we are going to do is we are going to find out all those guys at assigned equal to this dot people dot length. So DP of this dot people dot length at this point is all ones. Wait, this is assigned, right? Yeah. So DP of this and this is equal to 1 for all. No, that's the only DP which is equal to 1. Yeah. Right. So this is it, right? This is the only position when we actually give out 1. Otherwise, we always give 0. Right? That makes sense. Okay. So people have to be this and the. Fine. So we get rid of this condition, thankfully. And now what we say is, we are going to be moving bottom up. So what can we do? Well, from 0, if it has already not been assigned, should top down work here? I don't know. It seems like, will it ever touch the same people? Yes, it will. Yes, it will. It will touch the same people, and it will touch the same assigned. So you know what? It's weird. Let's keep DP. It's not going to affect anything. In fact, no, it's making the code dirty. Let's go for top down. I think it'll work out. Nothing special about bottom up so much really. All I need to do is, in fact, yeah, the same array top down sort of can be used. I'm not going to call it DP. I'm going to call it actually visited, and it's going to be Boolean. That's the only thing. This is a Boolean array. If it has been visited, then we don't visit it again. We just right. No. Visited, but yeah, really, but we need to store the value also. So yeah, this is fine. Long is fine. So if it has a value, initially we are going to be setting all of it to -1. So all of it has to be set to -1. All of it has to be set to -1. Should I really do that? It's going to take. Does it take time? Does it take time? Every time I create something, I'm going to be creating the whole new array. So DP, if it hasn't been done, should be done then. 10 test cases, right? So that'll be into 10. Yeah, fine. So I'll set the whole thing to -1. Is there some way to fill it easier, like beep fill or something? Oh, okay. Right. Everything is set to -1 initially. Every array in the DP is set to -1. And what we do is if DP of people and assigned is -1, is rather not -1, then we just return it. Otherwise we do this entire thing. But what we do every time is we set this value. Before we are going to return the answer, we just set this value to answer. Okay. And another place where we can do this is actually set this value to answer. Just call this answer. Right. Okay. It's long. So yeah. Let's just test it once before we submit our new top-down solution. So I'll tell you what's the difference between the complexities. What the hell? Okay. Excuse-moi. This is not gonna work because it's checking everything. So the first solution that we had, it has a complexity of n factorial into k, which is still not good enough. Okay, we need 2 raised to power n there. And the reason it is n factorial, okay, yeah, I just read some of your comments and I don't know. I'll have to like read them properly to understand what you guys are saying. But so the reason it is n factorial is because we are recomputing the states which we have already met earlier. So we are not doing it in a very efficient way. Okay. Now what? Now what? Now what? Well, is the DP thing first of all there? Yeah, DP. If this is -1, then yeah. Otherwise, we are actually setting it to answer. Okay. -1. Yes, this seems correct. Fire and forget. Come on, Coach Chef. You can do it. You can do it, Coach Chef. You can give an AC answer to a guy who's been for the last 2 hours to solve a simple problem. You can do it, Coach Chef. That's it. That's it. I mean, this is a simple problem, and I took all the time in the world to solve it. I'm so sorry, guys. It's been, you know, I'm sure it's an investment of time that you guys are giving, and it took about 2 hours to solve this problem. But yeah, I'm shamelessly happy even now because yeah, I solved it. Yeah, so that's fun. Yeah, so if you understood what's happening in the code, I'll just make a quick run through, guys. This is just the input and output, right? And now you can appreciate that this code works. So there's a solver which just takes all the shirts and makes an inverse mapping of them. Okay, it takes the people who you can assign the shirts to, right? Instead of so the state that we wanted, of course, is the number of people who this shirt can be assigned to, so that you can then assign those shirts and move forward. So that was initially explained over here in the diagram. So every state contains, as you can see, the number of shirts which have already been assigned and the people who they have been assigned to. So people is actually a set, okay, but I'm using binary to make sure that this set is maintained through bits only. So what happens is every time we come up to a possibility, we say that, okay, what is the next shirt that needs to be assigned? We assign it to every possible person. Okay, these are the persons who have not been assigned the shirt to. Through some binary manipulation, we find that out. And then we say that, okay, if this can be done, then add whatever answer you get to the possibilities. And there's this mod function, which I didn't actually, you know what? Initially, I thought that this is going to create some issues. But for God's sake, man, I mean, I really didn't understand how the logic was so convoluted. But yeah, maybe I thought it was convoluted and that's why it was taking too much time. But yeah, finally, what happened is we came to this solution, which is an n factorial solution, n factorial into k. So to improve on that, what we did is every state has to be visited just once. So that wasn't being guaranteed earlier. Now I made it a top-down approach by storing all those values which have already been computed previously in this DP array. And so, yeah, we have finally solved the solution. Yeah. Yeah. Okay. So guys, 2 o'clock, pretty late for me. I sleep at around 4, yeah, actually, to be honest. But yeah, this shouldn't have taken so much time. I'm going to be making a different video on this, of course, which is going to be much shorter and much more to the point. But this was more of a fun thing, to be very honest with you. It was just like, oh, I'm going to do this live. And 10 minutes before or 15 minutes before actually going live, I just thought, oh, wow, what if I go live? So the reason this thing started late was because I didn't have software to actually go live. And then I realized that Hangouts can, do the same job. So yeah, little elephant and T-shirts. It's created a big elephant problem for me. But it's fun and we have solved it. So hopefully we understand DP with Bitmask at least the basic part pretty well now. And do you have any doubts, by the way, guys? There's 13 of you. So in case any of you have any doubts, let's... Whoa, what's this? Yeah, okay. I see that there's some lag or some issue like that often. Huh. Oh, what is the ES problem you're talking about, Saurabh? Or we can take this offline, actually. I mean, you can comment on some other video, which is... yeah, the end part. You're talking about the top-down approach, probably. Yeah. So what happened is, let's come back to the diagram, right? And let's just get rid of this thing. I'll choose a good color like blue. So what's happening is that every person is being assigned a shirt, right? And we are taking the state as number of shirts assigned, and the set of people who have already been assigned the shirt. This is what we had. So what I'm saying is that, let's say 101, and the number of shirts assigned is 3. This is one of the states. Now, there might come a possibility that the first person is assigned a shirt 1, the second person is assigned a shirt 2, and now, therefore, we have come to the third shirt with 101 as one of the states. Another possibility is that 2 is assigned to person number 1. 1 is assigned to person number 3, and person number 2 is still not assigned anything. So you see that it's the same state. It's the same number of people who have been assigned shirts here and here. And the number of shirts, the shirt which needs to be assigned is shirt number 3, because 1 and 2 have been assigned. So you see that these two states are duplicates. Now, it's not creating any issue in terms of correctness. We are getting the exact same answer. But the thing is, why not store this state if you have already calculated it once? Because this is going to give the exact same answer. Now, if you don't store that state, what's going to happen is, from the first position, you have n possibilities. Okay, at least one person will be assigned a shirt. So you'll have n possibilities. From the second place, you'll have n minus 1 possibilities at most, because at least one person is assigned a shirt here. So n minus 1 people remain, and n minus 1 possibilities. And so on. Even here, you'll have n minus 1 possibilities. Even here, you'll have n minus 1 possibilities. Okay. So you see the first layer has n. The second layer has into, basically, the number of states is n minus 1. The third layer is into n minus 2, and so on. So what you're having is a time complexity of order n factorial. Into each state is also doing k computations to find out where it is assigned. So that is k, order n factorial into k. Okay, so this is too large. What we did is, if this state has already been computed, if this entire state actually has already been computed, we store it in a DP array, as over here, this DP array. So what happens then is that the number of states is confined to what? 2 raised to the power n, because that's the only number of binary values that this set can take. And the second one is the number of shirts, so that is into k. Okay, so order complexity has gone to this. Now, what's the difference between this and this? There's an approximation for n factorial. So 2 raised to the power n log n is the approximation for n factorial, order complexity. So this is what you had earlier, and effectively you have brought it down to order 2 raised to the power n. Okay, I'm ignoring the part of k, because that's a pretty small thing. So this is the saving that you have, and because n is 10, log n will be at least 3, a little more than 3. So 2 raised to the power 3 gives you around 8. So we have improved the efficiency of the program by about 90%. It takes just 10% of the time that it required previously. Okay, it runs about 8 times faster to make things simpler. So is that clear? Yeah, long, fine. Yeah. Okay. So, guys, I think we are done with this program, with this problem. I'll be picking up a different problem from Bitmasks, probably slightly, more concise and a little tougher, because if I'm solving it on the blackboard, I can show my skills in a much easier way than on IntelliJ, I guess. So, but yeah, good night, best of luck. Thanks, guys, for watching and for being so patient. And thank you for actually coming for the very first live stream. It's a very, I feel very privileged to actually have you guys on the chat. So thanks and see you. Now, if I only know how to shut down the live chat, that would be an end to everything. But yeah, right. Okay.